Alright, 8th graders, lesson 61, sequences here. Sequence is just an ordered list of numbers, and each number is called a term. And in the sequence, there has to be a rule or pattern. Like 3, 6, 9, 12. We can see that in each case, we're adding 3. Okay. And increasing them, or you could say I was multiplying that number by 3. So if this is a 1, this is a 2, this is a 3, and this is a 4, we multiplied those by 3, we notice that we would get each of the numbers that's above them. So we're looking for patterns is what we're really looking for. And this is example 1 right here. We're adding 3, so the next 3 terms, if we get rid of maybe some of this red line here, the next 3 terms would be 15, 18, and 21, because each time we're adding 3 more to each of them. So this is called an arithmetic sequence. And the reason it has that name is here we see kind of arithmetic, which is usually associated with addition, but it means there's a constant difference. And the constant difference is up here. They always stay the same. It's not changing. Okay, so that's called an arithmetic sequence, when whatever we're doing to each number is staying the same, and it's a constant. So that's what we're looking for there. In example 2, we have 1, 3, 9, 27, and it looks like to get from here to here we're adding 2, but that won't work for the next. But I could multiply by 3. That looks like is going on here. Each time I'm multiplying by 3. So the next 3 terms, let's see, that would be 81, that would be 243, and it would be 729. So again, we'd multiply each of them by 3. Now this type of sequence is called a geometric sequence, because it has a constant ratio between the terms. If I were to take the first 2, that would be 3 over 1. Or if I were to take the second 2, that would be 9 over 3. Or if I were to take the third 2, 27 over 9. Or if I were to take the fourth 2, 81 over 27. I can reduce all of those to 3. 3 goes into 9 3 times. 9 goes into 27 3 times. 27 goes into 81 3 times. So because there's a constant ratio between each number, then we say that this is a geometric sequence. Alright, going back to kind of our first number, we can also talk about the position or the term. Like if I said I put in a number for n, what would be the answer that I would get out? And again, I'd have to do this math problem in here, n times whatever we're doing. So I could make a nice little chart here, and an A. And in the example of the first problem, put all these up here, the terms. The first term was a 3, the second term was a 6, the third term was a 9, the fourth term was a 12, the fifth term was a 15, the sixth term was an 18, and the seventh term was a 21. Okay, so this type of sequence again is a arithmetic sequence. Okay. If we go to our geometric sequence that we just did, good enough. We had n and a, and n was 1, and 2, and 3, and 4, and 5, and 6. And the first number was a 1, the second number was a 3, and then a 9, and then a 27, and then an 81, and then a 243. So that is a geometric sequence, again, because we could make a ratio. All right, example 3, write a formula for the sequence. We've got 3, 6, 9, 12. We're adding 3 to each term, but we also had said earlier on, if we put that in a box, we make this N and this A. We put in the first term, second term, third term. So what we're going to say is take N, whatever number you want, multiply it by 3, and that will give you the answer. Okay, so we're going to multiply N times 3 to get A. Now you see in your book they have this little N down here. That's called a subscript. It tells you the nth term. So we can put in any number that we want over here. The fourth number would be 4 times 3 is 12. And that would be our answer there. Alright, in example 4, we want a formula for another sequence, and this is our geometric sequence. Again, if I put it into a box here, first, second, third, fourth number there. So we've made this table. Now we just need to figure out what are we going to do here. Well, if I put in a 1, I get out a 1. If I put in a 2, I get out a 3. If I put in a 3, I get a 9. So what I see here is something growing exponentially. So I want to use an exponent because it's growing exponentially. So I can look up here and I can look at, well, let's write it down here. 3 to the 1 would equal 3, but I don't have a 1 up above the 3. I have a 2 up above the 3. So how could I do that? I could subtract maybe 1 from the exponent. So let's try that here. I want to get just a 3, so I'm going to say 3 to the 1 minus 1 will equal 1. 3 to the 1 minus 1 will equal 3 to the 0, because 1 minus 1 is 0. 3 to the 0 equals 1. So that works. So my formula that I think I've come up with is take N, that'll be this first number, and then we're going to say minus 1, that's the number you put in, and then there will be a big 3, so this is the exponent over here, and that will tell us what A is, or A again, we have to put that little N in there. So we'll try that over here on the right side. I'll take 3, and let's say I want to find the third number, so I'm going to put in a 3 up here, because that's the third number, then minus 1. That will equal A. Alright, so 3 minus 1 is 2, so 3 squared equals 9. So that's true. The third number was 9. Let's try it for the fourth number. Take my big number 3, and the 4 goes where the letter N, because that's the fourth number, so that's going to go in here. So I put a 4 minus 1 will equal A. Now 4 minus 1 right here equals 3. So I'll put in the 3 to the third, and that will equal 27. So this is a correct pattern. So if we go and try to, well, we don't want to. So my formula here should be 3 n minus 1 will equal the answer for the whatever term, answer for the third term or answer for the fifth term. So we could go ahead and we could put what would be the fifth term. It will be 3, and because it's the fifth term, we put a 5 up there, minus 1 will equal A. 5 minus 1 is 4, so 3 to the fourth. So that would be 27, because our last number, the third number, was 27, times 3. And we know that's going to be 81. So that would be our answer. So for the fifth number will be an 81. Alright, that's it for today. Take sequences very carefully and slowly, but you should get started on it.